Hey guys, it's Mrs. Hageman. I'm going to take you through 5.1 angles of a triangle Desmos activity. This was done Monday and Tuesday of the week of January 25th. So come see this video if you need any slides redone for you or if you were absent because of the PSAT. So this is 5.1 angles of a triangle. We're going to talk about angles, sides, and how to find missing information. So naming a triangle is pretty important. You can name it with 3 letters, all capital, and the order does not matter when you have one triangle. We will see that the order matters when we're comparing 2 triangles to each other in 5.2. So think of another way to name this triangle with 3 letters. And so as long as your 3 letters do not match, make sure you put triangle in front. So we're not talking about an angle. So this could be triangle CAB, ACB, BCA, etc. How to name angles in a triangle. So this is color-coded for you. Just as in chapter 1, we were naming angles. The same concept applies when working with triangles. The vertex of the angle must be the middle letter, and it can be written in 2 different ways. Notice in the picture for the green part of the triangle, angle B is written as angle ABC or as angle CBA. In both, B has to be the middle letter of the 3. It doesn't matter which the 2 you use, okay, but B has to be the middle. And again, naming angles is going to be important, especially for the next section when we move to matching up parts of triangles to each other. Slide 4, along with some future slides, is an exploration here. So you can move this triangle around and look at the angles, which are on the inside, and the side numbers on the outside. And we want to look at the largest angle. So I'm going to stop here on 104. So the largest angle is always across from the longest side. And in my case, they're both red. The smallest angle is always across from the shortest side. And again, you can pause this video and experiment a little bit. So May says that she has a triangle with angle A, 40, angle B is 60 degrees, and angle C is 80 degrees. She would know which side had to be the longest without even drawing the triangle. Do you think May is right or wrong? And then we're going to explain her thinking. So if she's right, let's see what side is the longest. So using the previous slides, the smallest angle is always across from the smallest, and the largest angle is always across from the longest. So if angle C is 80, that means we can tell which side would be the longest, okay? So the longest side would be across from, also known as opposite, the angle C. And if you're naming the side would be AB, because that's not including point C. All right, just to double check, the smallest side of a triangle is always opposite the smallest angle. The largest angle of a triangle is always opposite the longest side. And I do want to point out on the previous slide that it said sides. You can go back and forth. So the smallest side is opposite the smallest angle and vice versa. Slide 9. Now this was not talked about, but we sort of have to apply our thinking if we have equal angles, like an equilateral triangle or an equiangular triangle, or any triangle that has equal angles to it. Are those opposite the smallest, opposite the largest, or opposite equal sides? Those would be opposite equal sides. And we see that with equilateral triangles and isosceles triangles. So if we have an isosceles triangle with equal sides, then those angles that are opposite are going to be equal. So here's a summary slide. It is also the same as your vocabulary sheet that you did. Scalene, isosceles, and equilateral are side classifications. Acute, right, obtuse, and equiangular are how to classify by the angles. Okay, so make sure you know which is which. And you can use both at the same time. So you could say something is a right scalene triangle, for example. You also had a chance to explore these when you did the Kahoot assignment. Types of triangles. So drag the vertices of the triangle to explore, no matter how we move these. Okay, we don't have sides. I'm sorry, we don't have angles, we have sides. So that's why these are our only choices. So we're not looking for acute or right or obtuse. We're looking at the sides here. So all of these sides are different, so it's scalene. Slide 12, no matter how you drag these, it's always going to maintain that two side numbers are equal. Okay. So 6.26, 6.26, so this is isosceles. And then you also have talking about interior and exterior angles, again, from your vocabulary sheet. And then I'm going to pause this video here and we'll do another video for calculating missing angles, part 2 to come.